Alrighty, so I'm going to do the word problem part that I skipped the other day. I wanted to wait. I know it doesn't matter because you can watch them in whatever order, but I wanted to wait until we had done them in class. So I'm going to do them now, and my dog is going to chew on this bone right behind me, so you're probably going to hear weird sounds, but that's always on my videos. Okay, I don't really care what order they're in, I guess, so I'll just go. I do like to think about what form they're in. So this first one doesn't have an equation, but it's a revenue problem, and revenue problems are always the ones that are going to be in intercept form. We did one of these in class, and I want to make sure you feel like you understand how to do them. So keep in mind your revenue is always going to have a factor like inside the parentheses for money, and then one for the number of items that there are. So when you go, it says write an equation that models the projected revenue. Your revenue equation is always going to look the same. It's going to have two big fat sets of parentheses, one for money and one for items. So a Converse wristwatch at Macy's sells for $50. That strikes me as money at a rate of $45 per month, meaning they sell 45 of them every month at that price. So that's the beginning of my number of items. The marketing department determined that for every $2 decrease in price, now keep in mind, in these, X is always representing the number of price changes. Should you decrease the price once, twice, 3 times, $2 each time? So if you're going to decrease, you're going to subtract 2 times, however many times you make that change. But as you decrease the price, it says 3 more watches were sold. That would add to the number that you sell. In these problems, these will always be opposite. One's going to be plus and one's going to be minus. Because if you increase the price, fewer people buy them. If you decrease the price, more people buy them. So, okay, now I have to figure out the new price and the revenue, it looks like. But in order to do any of that, I have to figure out how many changes I need. So this is kind of tricky, and that's why I made the video of the notes for you to watch, and I'm making another one for you right now. We need to find the 0 for this part and the 0 for this part so that we can figure out the number of changes. And that's going to come from the 0 of the first part plus the 0 of the second part divided in half. That's going to tell us how many price changes to make. So in order to do that, we take each thing and we set it equal to 0. I take the first part and the second part and set them both equal to 0. And then you solve. So I'm going to take away 50 to the other side, and then I'm dividing both sides by -2. And the negatives cancel, so that's a positive 25. In this second one, I'm going to take away 45, and then I'm going to divide both sides by 3. So that tells me that the 0 for the first part would be 25. You'd have to put a 25 in there for 50 minus 2 times 25 to be 0. The 0 for this part is apparently a -15, because 3 times -15 is -45. So when you add that to 45, you get 0. So for us to figure out what's the number of price changes, we're going to take that number that made the first part 0 from right here, and we're going to add it to the number that made the second part 0 and divide it in half. So 25 minus 15 is 10/2. So we're going to have 5 price changes. If you change the price 5 times by $2 each time, because it's set up here, they're going to decrease it. If you did that 5 times, you're going to maximize your revenue, because this is the X part of the vertex, and that's going to be our maximum. So this is asking about the new price. Well, this first part was the price part. So the new price is going to be the $50 that it used to be minus the $2 changes, and they're making 5 of those changes because that's what we just got was 5. So that's where that came from. So 50 minus $10 worth of change means that the optimal price is 40 bucks. If you price the watches at $40, you're going to maximize your revenue. So if you do that, it's saying, what would that projected max revenue be? Well, revenue equals the equation we drew up here or wrote up here. I just found out the new price, but if it makes you happier, you can just type the whole thing in, putting the 5 that we got as our X in for the X. And then 45 plus 3 times that X that we got. So again, you're saying, hey, what's the new price? We already did this part, got a 40 on our calculator. Here, if I do this part, I'm going to find out that that will sell 60 of them. But you can also just take your calculator and type all of this in straight away with parentheses and all. So you would just do parenthesis 50 minus 2 times 5 parenthesis. Then another opening parenthesis, 45 plus 3 times 5 parenthesis. And you end up with a oopsies, you can't write with a highlighter, max revenue of $2,400. Because the best possible price is 40 bucks, and that will sell 60 of them. So I get that 2,400. So that process is complicated, but just walk yourself through it a few times and see if you can't kind of get the hang of that. Okay, the path of a jump by a dolphin can be modeled by this function. Now, I am changing this to be in standard form because then we've practiced one of each. So I'm just going to multiply it out. You wouldn't have to do this on your own. And I'll have negative 0.4x squared plus 4.8. So we're just going to pretend this doesn't exist and that they gave it to us in that other format because I want us to practice each type. Okay, so you look at this problem and you go, okay, this problem is in standard form. So I look at my chart and I'm only going to use the things that are in the standard form part of that chart. So ignore this because we just answered that as standard. All right, so you know that generally speaking, it's going to go up and then come back down. You know that this high point will be the vertex. How far out that occurs is the X part. How far up that goes is the Y part. You know this is your Y-intercept. And then you know that this, how far this is going to be 2 times your X part of the vertex because your vertex takes place halfway. So, like we talked about in class, if it takes that long to go up, it's going to take that long to go down. So I'll double that value to find out how far it goes altogether. So we need to find all those things. So let's start looking for the pieces that we know. I'm not even going to really read the problems yet. I know that in a standard form, to find that X part of the vertex, I need to take the opposite of B. So, oops, sorry, I forgot an X up here. Here, the C value is 0 because it doesn't have one. So that's why I also know that this is at 0, 0. My intercept is 0, 0. Started at the bottom. Okay, so I do the opposite of B over 2 times A. So again, use your calculator, but you got to do it in a way that's going to make it correct. If you're going to divide by the bottom, you need the whole bottom to be in parentheses. Use your negatives. All of this turns out to be 6. So what does that mean in my picture? That means it's 6 this direction. It says X is horizontal in feet. So that's 6 feet, which means it's 6 more feet before it lands. So 12 feet total. My guess is they're going to ask me about that. I also probably want to find out how high it can jump. That's going to be Vy. And Vy comes from going back to the original equation. And I'm not going to have enough room, so I'll move that. Oh, well, this is the question right here. This one says, what is the max height? Max height is that V sub y. So I find that by taking my original equation, negative 0.4, and then in for the x, I'm putting the x that I just found. and then plus 4.8 times x. So just make sure that you have the 6 in both spots and that the first one got squared. So type it exactly as you see it, negative 0.4, parentheses 6, parentheses squared, plus 4.8 times, and then parentheses around the 6. I am getting that is 14.4. And what that means in this picture is that from here to here, from the top to the ground, or I think it's water, this is going to be 14.4 feet. Yeah, it's a dolphin. So it's coming out of the water. So that is how high it can jump. It can jump 14.4 feet out of the water. That's its maximum height. This one says, how far does the dolphin travel? Like one jump. Well, it travels this far. So that's where we did the doubling our v sub x, which was doubling a 6, which told us that the whole jump must be 12 feet long because it was 6 to the middle, 6 back down. So the types of questions that this is asking you about each thing are the types of questions you should expect to see on the test. So let's do the last kind. We just had a little Diet Coke break there. Sorry. Not sorry. Okay, take a little peeky poo at this and you go, oh, look, that one's in vertex form. So I go to my chart and I focus all of my eyeball energy on just the vertex column. I love vertex form because it's so easy to find the vertex. I take the opposite of what's in here and then I use this number as is. There, that's my vertex. Now I just have to figure out what they're talking about. The height in feet of a baseball t seconds after it is hit is given by that function. Okay, so we don't have to graph this one, but basically you have a baseball. It's not on the ground because it gets hit in the air and then it goes zoom like that. We know the vertex is 3 feet, 148. So pop fly, I guess. What is the max height? Okay, well, if this is the vertex, the max height is going to be the y part of the vertex. So I don't have to do any math. I just say 148. Okay, it's in feet. Feet goes 148 feet up. At what time? So across the bottom, that's my time. So that's an X question. At what time in flight does it reach the max height? So it's asking you for v sub x. It's saying where along this timeline of this hit does it actually reach that max height? And we already found it by just looking at the original equation, and the answer is 3. And since it's time in seconds, that's 3 seconds into that hit. Okay, who can determine what the height? Yeah, okay, you know what? I'm not going to make you do that. What you would have to do, it's asking you how high is it when t equals 0. So you would be plugging in a 0. This is not something you have to do on the test for the word problem. But that's going to make it a height at the beginning because like I said, it gets hit at a height. Like when you hit a ball with a bat, it's not on the ground, hopefully. That's called golfing, I think. So I'm going to do negative 16. I'm going to put a 0 in here. And that's going to tell me when time is 0, I haven't quite hit it yet, like the nanosecond that I did, how high was it? So I'm typing that in exactly as it appears with the parentheses, the 0, and the whole shebang. And I'm getting 4 feet, which just means that this started 4 feet off the ground, got hit, zoomed up, came down, and landed. Unless someone caught it, who knows? Okay, that is the grand finale of that. There's an answer key online, I hope. If there's not, I'll put one there. What I might do is cheat and upload this whole thing. We'll see. I'll get a key on there so you at least have something to look at. See you soon. Bye.